For the controller, we shifted over to the workbench. So this is the NetGain Industrial controller. It is a commercially available DC motor controller. This is a little older model. I'm not sure it's actually available anymore, but it has several connections. It is rated at 400 volts, 1000 amps. It's actually a very nice controller for flexibility. You supply 12 volts to the electronics. So the electronics inside here that run on 12 volts are fed separately. So there's no DC to DC converter inside that is expecting a certain voltage range. So you can give this thing anywhere from 24 volts to 400 volts to drive a variety of motors in a variety of configurations. It is for prototyping. I think it's going to be very good for me, so that I don't need to use a variety of controllers to test out different voltages of motors and different sizes. You can limit the current to whatever you want. You can limit the battery current to whatever you want. So if the battery pack can only supply 150 amps, then that's all that you take out of it, and you get the performance from your motor depending on that. There is big connections for the motor, plus and minus, and big connections for the battery, plus and minus. There are two connections, these two, which use a network cable, but it's not actually a network. It's actually a connection to a programming panel and to a data logger. This is the throttle cable, and it's the one I'm having trouble with when I connect my accelerator up to it. It gives me a fault code. And then this is everything else. So these two go across the pre-charge resistor to tell when the capacitors have almost been fully charged. That's when it brings in its own contactor, which is part of this. There are signals for a brake. There's an ignition lockout. There's 12 volts coming in. There's a variety of signals in there. Anyway, probably too much information about that one, but this is the NetGain controller. It is also liquid cooled. I should probably show you that. So the copper pipe coming out here is, and I don't know which one's in and which one's out. That's marked on the bottom. But you circulate coolant through here and run it through a radiator or however else you're gonna cool it off, just like a regular car. So there's no way you can pull enough air across the heat sinks to keep this thing at 400 volts and 1000 amps. So they provide for liquid cooling, which is quite a bit more efficient. And you can have enough fluid in the system that it can take away most of the heat for very short periods of acceleration. Like you're going to be accelerating with traffic, you're going to be accelerating for 5 or 10 or 15 seconds. The system is going to get quite hot. The coolant is going to take the problem or the heat away, and then it'll have until the next time you hit the accelerator to circulate it through the radiator and pull air through it and get it back down to a reasonable temperature. This is the 2006 Honda Civic accelerator pedal with its connector on the side, and we have the pin out for what each of these wires does. And one of my tasks is to get this connected up to the controller in such a way that it does not cause faults on the controller. I haven't spent a lot of time on it. I actually tried to order a part from NetGain so that I could just plug the accelerator into a connector. It would just work. I'm having trouble getting one out of anywhere. Apparently they haven't sold a lot of them, and no one stocks them, and no one seems to be interested in ordering them for me.